So let us see about Windows diagram in this PPT. So what is basically Windows diagram? It is a circular graph that shows the direction and speed of wind at a specific location over a set of period time. It is of two types, which is type 1 and type 2. So let us see about the type 1. So type 1, this is used to determine the orientation of runway, where the wind data will be collected for certain years, that is 5 or 10 years of the airport which we are going to design. So the average data obtained should be sufficiently accuracy to obtain a good graph. This may be vary considerably from site to site cause of the change in wind direction or the wind. It depends upon the topography, and then this shows the direction and duration. So we are going to see a diagram drawn using the type 1. In this diagram we can see the radial lines and the circular lines. So let's see what this represents. So the radial lines indicate the wind directions, and the average wind data obtained for 16 directions, which are the north, south and the intermediate directions. So each direction covers an angle of 22.5 degree. The wind blow may be assumed from point to point, which is somewhat 22.5 degree. So the each circle in these radial lines represents the duration of the wind. So from this graph we can obtain the best orientation of the runway. So the values of durations from the wind data which we collected for the past 5 or 10 years is marked in that graph in all the directions. So this plotted points are joined in straight lines. The best orientation of runway is usually along the direction of the longest line in Windows diagram. This direction of longest line is calculated with the values that we have plotted in the graph. So the wind coverage. With that graph, we will come to a conclusion of wind coverage, where it is assumed that the deviation of direction permissible is up to 33.75 degree percentile of time during which a runway can be used for landing and takeoff. This can be obtained by summing percentage of time along north northwest, north north northeast, south southeast, south and south southeast. So the type 1 diagram which we obtain using the data is like this. In this we can see that the north and south has the longest section, so it will be taken as the best runway. So the next is type 2. In this, the wind data used for type 1 is used to type 2 also. So here the difference is we are using a strip like thing so to find result. In this, it represents the wind intensity to scale. The radiance lines indicate the wind direction. Value entered in each segment represents percentage of time in a year during which wind have a particular intensity blows from respective direction. So the procedure to determine the orientation is we have to draw 3 parallel lines on a transparent paper with an equal distance apart. That equal distance measurement is given in our question itself. So they will be giving as the permissible crosswind component. So in this diagram I have taken as 25 km per hour for the distance between the 2 parallel lines. So by placing the transparent paper on the over the windrows diagram in such a way that its center line over the center line lies over the center line of the windrows diagram. So with the center of the windrows, we should rotate the tracing paper and place it in such a position where the sum of all the values of direction of wind bound by 2 outer parallel lines has a maximum value. Thus, the direction indicated by the center line, which has the maximum value, is the orientation of runway. So the wind coverage is calculated by adding up all the percentage of duration shown in the segment, that is in the transparent paper. This percentage of duration is assumed to be equally distributed over the entire area of the segment. So if outer parallel lines of the transparent strip cross a segment, proportional value is assessed and added. So with this thing, we are drawing the type 2 diagram, we obtain the result.